Hello and welcome to this demonstration of the prototype data warehouse which we are delivering with SeETL 3.1.02. My name is Peter Nolan and I'm the founder of Instant Business Intelligence. This is the detailed presentation. It does have a prerequisite of the summary presentation. We will not go over the comments made in the summary presentation again in this presentation. So if you are watching this one first, please go back and view the summary and come to this one second. Okay? We would appreciate that because that will be clearer for you. What we're going to do in this presentation is take you through the detail of what's being delivered in the download that you get when you download the prototype data warehouse. Okay? And the purpose of creating this demonstration and prototype is to give people, particularly in the .NET Nuke community, the ability to build prototype data warehouses, business intelligence systems, off the back of .NET Nuke systems quickly and easily, and extend that if they like. Now they can take the work that we have done and just maintain it and extend it themselves. Okay? Or if they like our tools and want to maintain the workbooks using our tools, then we would like a donation, a payment for our software, for the amount of time and effort that we will save people in building BI solutions on .NET Nuke, right? So because .NET Nuke is on SQL Server and because we build our software on SQL Server, we're making a point of it to provide something to the .NET Nuke community to, in all honesty, drive the need for our software if people want to use it, right? This is a win-win situation. We've gone away and done a whole bunch of work which is valuable to a large number of people. We're giving it away for free, and if people want to maintain that, maintain it your way or maintain it our way. If you maintain it our way, then there is a fee for the software that's involved, and it's as simple as that. So that's why we are delivering these prototype databases. It's quite clear why we're doing that. Further, we are also going to offer to the .NET Nuke community the ability to host your .NET Nuke BI solutions via our business partner in Germany if you want to do that. So for example, if you say, okay, well, I've got a website that's getting, say, 1 million hits a month or 5 million hits a month or whatever it is, and I want to host a BI solution. I don't want it with my internet service provider or whoever's web hosting. Let's say they don't do this stuff, but I do want a BI solution. You can have one of those through our business partner in Germany. If you want those and you go to your ISP and you say, Mr. ISP or Mr. .NET Nuke hoster, I would like you to offer us this service, please, and we're prepared to pay for it, then you already have this infrastructure to go with, and your ISP can come to us or your hoster can come to us and we can show them how to use all our tools and technology, right? So this is very clearly an effort to make BI solutions low cost and affordable for the .NET Nuke community. That's what this is. Okay? So we'll go through the directory structure, the components, the workbooks themselves and what they produce, and we'll go through quite some detail on the tables. Okay? That's what we're going to do. So first of all, I'll take you to the directory structure and show you everything in there. Now what you will get when you download this package is you'll get this directory, IBI hosting. Okay? Now I will take out of it some of the things that you shouldn't have. For example, backups of databases. You won't get that. You won't get data. The data that is in these databases, you won't get the data because it has people's names and email addresses and things like that, the registered users of the sites. So you'll get these things. I will just say at the moment that this is quite a long presentation, but you will have seen that from the YouTube video. So you'll get these things. There are three sites set up, one for IBI, one for IBI web hosting, and one for a thing called CAF. And we won't talk about that too much, that's a separate issue. But we do have a site called CAF that does get 120,000 hits per month. Okay? Obviously our own small company site doesn't get 120,000 hits per month. I live for the day that we get 120,000 hits per month to our site. Okay? So under IBI we have a staging area. Okay? And so under each of the directory structures there is staging and target. Now in staging, of course, we have DDL, and there's a whole bunch of different DDL that's required. Okay? So for example, you need to set up a database. In each of these we put an archive, and so if we want to change something, we take a copy, we throw it into the archive, we give it a number, and then we edit what it is we want to edit. So we send this to TextPad, and you can see it's just a create database statement giving a primary and a log, and it's putting into SQL Server data a hosting, a number, and an MDF. Now of course this is a demonstration and prototype. If you wanted to build big data warehouses, you would of course use file groups and all those sorts of things. Okay? So how you physically implement the data on the disk is really up to you. .NET Nuke out of the box delivers everything into the primary database, so we're just doing that for the data warehouse. Yep. So you can look at that. Tables. You can see that there are 626 items in here in the tables. CTAS is create table as, so I can go and open up that, and you can see spreadsheet name, drop the table, select into, from, and this is VF campaign dims ASOC where 1 equals 2. So you all know that that is the statement that will actually create the table. Okay? And you can see from this that it's generated. And the Windows domain was IBI Prod01 and the Windows user was administrator. Okay? So you can see that. And you can see it was the SeETL design time was built on the 7th of the 7th, early alpha development, and you can see the timestamp for this was the 28th of the 7th. Okay? So this gives you an idea of what's coming out in the SQL. So you see the CTAS, you see control tables. So for example, batch run log, we'll just go into there. And here you go, you can see drop table, batch run log, create table, and it's got a batch number, process batch name, started, ended, status. So pretty simple. And again you see that it's generated. Okay? You can see the comments which were generated. Now all these control tables which you see here, I'll show you how they're all generated out of the workbooks in a minute, but the documentation tells you everything about these tables. The workbooks tell you what data goes into these tables, etc. It's not very difficult to understand all these tables. And there are quite a lot of control tables now. Then you go into staging tables like STG address, and you can see, it has a key, there and varchars, you've got address lines, cities, suburbs, building type codes, paper mail, email, primary residence, business residence, all these sorts of things, user data, row deleted from the source, row valid indicator, row sent to EDW, row sent to ODS. Okay, so this is a very standard staging table for addresses, and this can be loaded up from a workbook now. Okay, so if you're a business with 50,000 addresses, you can actually load this thing just up through a workbook. So that's what's in addresses. Of course, we then come down to all the staging tables for the .NET Nuke tables. Okay, so what we'll do is we'll look at forums, and I'll open this with TextPad, and I'll show you what goes on for creating a staging table. So everybody who's looked at .NET Nuke will know what the forums table looks like. We've combined the elements of different forums. So this is a superset of a couple of versions of the forum software. We add a source system number. So this tells us from which source system something came from. The forum ID also gets a PK put in front of it. So obviously if we've got multiple .NET Nuke sites and we're feeding multiple forums from multiple sites into a single database, the forum ID is part of the key and the source system number is part of the key. So you can tell what's part of the key by seeing PK underscore. DK underscore indicates that it is a detailed key, and the detailed key means that this is the primary key somewhere else, and this key links to that primary key somewhere else. We like to use DK underscore to indicate this so that people who are looking at the table can easily see what are the foreign keys on this table. And this is a standard that we've had for a long time. Okay? So most of you will have seen something like that before. We then add to the table row del from source indicator. So if the row has been deleted from the source system and this delete has been detected, then this will be set to 1. Row valid indicator, we provide the ability to write applications and queries, etc., to go over the top of the staging areas and set the row valid indicator to 0. So row valid indicator will always default to 1 as the data comes in, and then you get the chance to run validation routines to set it back to 0. And if it's set to 0, then it won't flow through to the data warehouse. So you have to decide for yourself what are the conditions under which we don't want a row or portion of a row to flow through into the data warehouse. We then have row set to EDW. This is set to 0 when it comes into the staging area because the row hasn't been sent to the warehouse yet. And this is how we do the extract from the staging area with an incremental update. Now if you want to have an operational data store as well, we provide the row sent to ODS indicator as a separate indicator. So it is possible to have different processing cycles for ODS and EDW. Okay, that's what that's all about. And that gets added to every staging table. And you can see that we've put it on primary. Okay, so every .NET Nuke table gets something like that added to it. Now I've scrolled down and opened up the ZXT DNN forums tables, and M1 is the -1 version. So this is created to look exactly like the table that's coming at us. Now this particular .NET Nuke SeETL031 is using an old version of the forums. So this table reflects the older version of the forums as the -1 version. Okay, and nothing has been added to this, just the field names have been changed. Then there is the Delta 1 table underscore D1, that's the standard naming standard. Same thing, it has the same fields on it, but it has at the end a column called Delta End, which is set to 1 for insert, 2 for update, and 3 for delete as the standards. Okay, so as it does the delta processing, it will set that flag and tell you what has happened to the -1 version to get the current version. Okay, so this is what's in the tables directory. Now the way that we actually deal with so many different objects, 626 of them, is we will type them into a single piece of text that is typed using the DOS command type, and you can see here that we've got 24,471 lines of create table statements, obviously with a whole bunch of comments in there. And we can just go run that against the database. Okay, so those are the tables created against the staging database. Naturally, we have indexes on these tables. You can see there is, just go back here, 288 items in the indexes. So the D1 and M1 tables currently not indexed. If we wanted to index them, then we could index them. Okay. So we can open up an index, and it's standard. Drop index on control audit table, create unique index on control audit table, and it's created on program name, file name, start timestamp, end timestamp on primary. So a whole bunch of indexes, 280 of them. Okay. Stored procedures, just the one set of stored procedures. These are the stored procedures for the reports, which you are just about to see. So we'll scroll down to the bottom, and you'll see you get 8,721 lines of stored procedures, which you can obviously go read and understand. There's not really any great need to read or understand them. You just install them, put the reports over the top, and then you have your suite of reports for the ETL subsystem. Okay. Then there is the views directory, and there's quite a lot in the views directory. Again, 153 items in there. Most of them are these ZIN items, where we're just looking at an input for the table that's coming in. So ZIN, meaning in, with Z at the front just to sort it to the bottom of the list. Drop views, ZIN ASP.NET applications. Create views, ZIN ASP.NET applications as, select star from, and here we see the name of the database, which has been unloaded from our web hoster and put into the same machine as this one. So this is creating a view, ZIN ASP.NET applications, just pointing at the very source table. So the ZIN views pointing to the source table. Now if perchance you had things like different collation sequences or something else like that between what you wanted in your data warehouse and what was provided in the operational system, what you might actually do is load the table to get the translation to happen between the different collating sequences, and ZIN would actually be a physical table inside the staging area. Okay, so you do have to take care of the different collation sequences, because as you probably already know, if you deal with SQL Server, if you try and do equality tests between fields of different collation sequences, it will ask you to specify how you want to do that. And our delta detection tools don't allow you to specify that. You have to be using the same collation sequences. Okay, it's kind of hard to add that feature onto every query, every equality test that's going. So you're much better off to get your data into the same collation sequences for both your source data and your -1 data. Okay? Now what we're going to look at is, after the ZIN views are set such that you are pointing, either the views or tables are set such that you're pointing the delta detection to the source data, you actually have to pull the data out of those tables or views, and these are the ZXT views. So ZIN means what's coming in, ZXT is what's being extracted out of what's coming in. So you can see ZXT DNet ASP applications is creating a view as select 1, which is the source system number. This is SeETL031. It's getting ZN ASP.NET applications application name, so you can see the prefix there and the column name, and you can see the aliasing over here. So the application ID is actually part of the primary key, and that's what's marked as primary key over here. And it's coming from ZN applications. Okay? And you can see that this is done for every table. So if we scroll down here, you will have this code. You can go and open it yourself, and very likely you're best off looking at this as we're going through this process. So this is 2,895 lines of SQL setting up these ZXT views. The next thing is just some staging views. So we're setting up STG campaign over the top of some staging tables, and these have meaningless names underneath, and they're given meaningful names over the top. So these are just, rather than having a stage campaign table, we have a number of these tables that we just then put a lot of different stuff in. So we have stage campaign, we have campaign group, and we have sub-campaign. And they're all in the one table. They just happen to have different table numbers. So 112, 111, and 154. Okay, as it happens. Campaign priority goes into a different table, TS003, and has a code name of VM campaign priority. And campaign type goes into TS0003 and has a code name campaign type. Okay, all not very complicated. So those views are there. The next set of views which are important are actually the staging views, and we'll show you how they're generated a little later. But you can see that they have things like Z01 VM Party 01, which is obviously a mapping for VM Party, and VM Party is people, companies and households. And you can see things like 1X, coalesce, the contacts. This is from Outlook contacts. So if you have, a couple of thousand contacts in your Outlook database, then you can get your Outlook contacts into our data warehouse using this mapping. And this is the table from Outlooks directly downloaded from Outlooks. And so you will see these things as the Outlook characters, Outlook fields. We're using a char index to go through the Outlook categories to set flags. So this is a good example of using char index to set flags on a party table. Okay, so you can see that. And this will be covered in the mapping spreadsheet. But you can see that this Z01 VM Party 01 is placed over the top of STG Outlook contacts. Okay, so we can take our Outlook contacts, put them into STG Outlook contacts, and run them into the data warehouse. Okay. Now the next piece of this, you see it's doing a left outer join to CTL batch control, where the batch complete flag is 0. So when there is a batch open for processing, it has a batch number on it, and the batch complete flag is set to 0 on the one and only batch that's open for processing. So CTL only allows one open batch for processing at any given time, and you can have batch processing groups inside that batch. You can see it then does a left outer join to CTL file cycle control using the batch control batch number and the file cycle control batch number. So it goes to the file cycle control table and grabs the file cycle control record for the current batch, and it puts the batch number and the file cycle number onto every record. So you can see that this is being emanated out there, batch number and file cycle number. And that's to give us the ability to track when the row came into the data warehouse from an auditability point of view. So we have batch number and file cycle number on every record inside the data warehouse. And the row needs to be valid, and it has to not have been sent to the data warehouse before. Okay? So this gives us the ability to tag rows as invalid and hold them, and this gives us the ability to only move the rows that haven't been moved before. And then just some other things about this, because this is common. Select last key allocated from CTL sequence numbers, where the sequence name is ZVM1 Party01. So we'll just go over to that table. Here we are in CTL sequence numbers. You can see we've just done a select there from CTL sequence numbers, and you can see the sequence name and the primary key that we've given it, and you can see the last key used. Okay, and this is just some test data, so we only have 133 parties in there at the moment. Okay, we have 53,000 page hits. We've copied the IP addresses across from the CAF database, so we have 144,000 IP addresses, which is inconsistent with 53,000 hits, unless you realize that that 144,000 is all the IP addresses across the three databases. So we have 112 pages, we have 55 forums, 787 forum posts, that kind of thing. So this gives you the last key allocated, and you have to maintain your keys, and we get the keys and set them through this process with the row number over partitioning by batch number, ordered by file cycle number, right? So this is just going to get us the last key and add one to it for each row. Okay, and if we just do, well, there probably won't be any data in here because the row set to EW will be set to yes. So ZVM Party02, this is for a email solicitation cancel. So if somebody says, please cancel any emails to me, it's going to set this no record is going to be sent to the email allowed flag. Okay, so we have a workbook which says, do you want to cancel emails? And if you put the customer's details in there, the email address allowed flag will be set to no. We have solicitation transaction. So solicitation date gets sent over to here. We have the solicitation key for the customer, for the prospect. Again, we have selecting the last key indicated. We have this string being sent to application system reference number string, which is a unique key, so that we can always key to a record inside any fact table through that field, and it's a key that's generated and maintained that we know is unique. And then there's all the things that the solicitation transaction might have, and this is from our Outlook contacts transaction. So we generate a solicitation transaction to go out to our Outlook contacts, so we want all the information about the Outlook contact to be also copied to the solicitation record. For solicitation number 2, that's going out as emails. So this is a solicitation email transaction. So that has things on it like the web address, the email file, the email file format, the subject, the BCC, etc., the SMTP host and port and password, and the variable substitution that can be performed in the email. So what's going across to the solicitation table is everything about that email solicitation. Okay? And you can go through and read this, and again we'll show you that it's about 2,000, just under 2,700 lines of SQL create view statements, which is going out, being emanated out to the staging area. Okay, the next directory to look in is the functions directory. There are only two functions being delivered as a part of what we are delivering. That is the integer to IP address conversion functions. And you can see them here. Integer to IP address typically just takes a big int and converts it to the IP address. Okay, you can see the conversion there. And IP address to integer merely takes the big int, merely takes the IP address and returns a big int. Okay, so that's what that's doing. You can see the addition there. So quite simple. In a number of our tables we store both the IP address itself and the integer that the IP address represents. Okay. After that, the next directory is the run stats directory. You can see there are 355 items in the run stats directory. And scroll down, and this is just commands to run stats against the various tables. And you can see from TextPad, here's how those commands work. Just tells it what database to use and issues the update statistics against that table with full scan all, which is the standard run stats command for SQL Server. Okay, nothing unusual about this. You can go click through a number of these tables. You'll see that they are pretty much the same each time round. Okay, so that's run stats commands. Now the next directory in the list is workbooks, but we're going to come back to workbooks and explain those at the end of this first part of this presentation. Next, what you get in the package is reports. You'll see A01 SeETL reports. This is the Visual Studio report solution. These are the two subsections. So you can see that there's some backup things in there. You can see that there's a series of report definition files. We'll just go here. You can see the report definition files. Okay, and you'll get those in your copy. We will take out the backups, and you can just deploy this reporting package into the database, and you'll be able to run the ETL related and metadata related reports. Okay, nothing complicated about this. Everybody who works with data warehousing in SQL Server has worked with report services reports. In the commands directory, you will see a series of commands which correspond to the names of the workbooks. And so the command just processes the workbook. And so we'll just open up a command. And the command is very simple. You see it executes SeETL console 3102. That's the new version. It says minus file name, which is an obvious parameter, and then you see it gives the name of the workbook. Okay, so A01 stage workbooks and then the name of the workbook, and you see that A0101 matches to A0101, and then it has a log file name, and it passes the name of the log file, and that goes into logs. Okay, workbook logs. So actually executing SeETL console is as trivial as executing any other batch command on a Windows machine. And you put that batch command into a file and you just double click on the file. That's how development is done now. Set in the workbook, type in the workbook, make the changes you want, double click on the file, go to the output to run it through whatever tool it needs to be run through. Right? In data, where one of the things we have in data is these temporary files or these work files. SeETL008 is our scheduler. So when you want to kill it, you copy the SeETL008.kill.no file and just change it to .yes. And when you change it to .yes, SeETL008 will detect that and kill itself, terminate. SeETL008.wait.no, when you create the .wait.yes file, you tell it that it's ready to start a new batch, and it will start a new batch. The way that you run individual batches within the scheduler, because the scheduler can have many batches defined to it, many batch names defined to it, you just create a file which gives the batch name .run.yes. So there is a thing called IBI-DWH, IBI warehouse, batch001.run. Batch001 in the schedule, and when you put .run.yes in this directory, that batch will run. There's a maintenance batch as well. So there are other things in here like backups. Obviously we'll remove the backup before we put this up onto our website, but we maintain backups in here. Okay, and we've deleted the other ones just for this demonstration. So that's the data directory. The other things are fairly obvious, are not particularly being used at the moment. The heart of the ETL subsystem, of course, is in DML. And the first thing we do is we generate deltas. So in this generate delta definitions, you can see there are just over 1,000 items in this one. 1,000 pieces of SQL to generate deltas. And what I'll do is I'll just open up one of these delta definitions. And the delta definition that I've opened up is for forums. As I said, everybody working with .NET Nuke understands what a forum looks like. So the first thing it does is delete, this is 01, delete from forums delta 1. Okay? Truncate everything from the delta table. So when it starts up and running, it assumes there might be some old data laying around in the delta tables. So let's truncate the delta table. Then it inserts into the delta table the select from the Z-extract forums, where the left join between the -1 version and the extract indicates that the record is new in the new extract. Okay, so the -1 version does not have this record in it, therefore it must be an insert. And the delta indicator is set to 1. So that's a fairly simple test. Get everything from the prior version, join it to the -1, joining on the primary key, and if it's not found, it must be an insert. The next one is to insert into forums D1, selecting from the extract forums and the -1 version, where the two keys are the same. So we're selecting when the keys are the same in the -1 and the current version, and check every field that you want to check in the row to see if it has changed. This of course generates an update. and the 2 indicates an update. So you don't have to worry about the format of this being laid out fairly messily, because you know that this SQL works and will be processed fine by the database. Now notice it tests to see if the fields are equal or both null. Okay, so if the fields are both null, that is considered equal, right? Whereas in most databases, null equals null is not equal. The next one, of course, is a delete. So it selects from the -1 table, joins to the forums table, the current extract table, and says, is there any row in the -1 version that no longer exists in the current version, which of course is indicative of a delete. And it issues a 3 on the delta indicator for the delete. Okay? And at the end of that process, the D1 table contains the deltas between the -1 version and the current version. Now we also have the ability to move the deltas forward to the staging area, and this is the next 4 pieces of SQL. We now truncate the -1 version and insert to the -1 everything from the current extract, so the -1 version becomes the current extract. It's the 4th piece. The 5th piece is we insert into the forums the staging table, everything where delta indicator equals 1. So we now issue that as an insert. Okay? We issue as an update to the staging area everything where delta indicator equals 2. So where we've detected it's an insert, we insert in the staging area. Where we've detected it's an update, we issue an update into the staging area, which means the staging area and the sources must be maintained in sync. Okay? You can't go doing things in the staging area and not doing it in the sources. And lastly, for deletes, we update the row deleted from source indicator to 1. Okay? We don't carry the rest of the data through because the data is not there in the current extract version. Okay? So that's our 7 pieces of SQL where that's our 7 pieces of SQL per table where we rub the -1 version against the current version, we detect the deltas, we store the current version to -1, and we move the deltas forward to the staging area. 7 pieces of SQL to get our current version into the staging area with delta detection. Okay, and only SQL, no C++ or anything else like that. So obviously with 7 statements per table, that soon adds up. You know, you have 200 tables, you have 1400 statements. But because it is SQL, it is very robust and you know exactly what's happening. And of course this SQL, if you want to, if you have large numbers of tables in your staging area to process, then you can parallelize this kind of processing. Okay? So that's what's in the delta detection directory. And as I said, in that directory you're looking at a shade over 1,000 items for this first one. And you have these, you can download and you can look at what's in them. Okay? The next thing is the row count. And what we do is we count the number of rows that are going to be processed and put the result into a file cycle control table, and that gives us a row count of how many rows should be processed in this run. Obviously this can be used to detect anomalies such as a large number of rows flowed in that was unexpected or something else like that. It allows you to then go count the various tables to make sure that number of rows did in fact wind up on the table, those sorts of things. So row counts were introduced as audit capability many, many years ago. And what does it look like? It's a normal piece of SQL. Insert into file cycle control. Select as a view name. Select the collects max with 0 and add 1 from file cycle control. But the important bit is this one, this piece. Select count star from DBO-Z01 VF response transaction 01, which is a view, as number of records. So it's selecting the count for the number of records and pushing them into the file cycle control, which of course does resolve that view. Okay, it does actually resolve the view to get the count. So the number of rows will go into file cycle control, and you can go and look at file cycle control and see that table in the database. And this is done for every single mapping. Okay, so web download, page hit transactions, all the mappings have the row counts counted prior to the beginning of processing. And then of course we come to the heart and soul of any data warehouse processing, which is the ETL processing itself. Okay, and in here we'll just get the number of objects. Not so many objects because we haven't mapped so much stuff in this prototype data warehouse, only about a dozen mappings. Okay, so 88 items, about a dozen mappings. And this ETL is again also generated. And let's just go and have a look. Look at parties. This is a mapping for, as I said, Outlook contacts. So you can see the first thing it does is truncate a temporary table. Then it inserts into the temporary table the select using the sequence and keys with a detail level column and the data from the party record. And this was from the staging views. This thing here is from the staging views, and it selects from that view. And that was the view you saw in 01 staging views. Okay, that's where that comes from. It will then take the data from the T1 table, where level column and dim chart key field are the same, and apply updates. Okay, so if this data has been seen before, then we will apply updates. Obviously, if this data hasn't been seen before, the T1 table joined to the party table tells you that we haven't seen this key before, then obviously this is an insert. And obviously this is a type 1 dimension as implemented. Okay. Another example is forums, web forums as we said, truncating the T1 table, inserting into the T1 table, the select from the staging views. And whatever complicated SQL you want to put into the staging views, it gets resolved inside the database, the view is materialized and then pushed forward into that T1 table. Now because there might be a very large amount of processing done in that view, we push it into the T1 table so that we only ever do that processing once. We don't want to do that processing for the insert and for the update. Okay? So we only materialize that view once in this piece of the processing. Remember, we do materialize that view again for the row count. Okay? So as you can see, that's the insert to the T1 table, the temporary table. We then do the update to the VM web forum table, which is obviously the data warehouse table itself. and we then do the insert into the VM forum table with the condition that from the T1 table we left join to the forum table and we don't find the level column and dim chart key field in the target forum table. That is, it's a new record. Now we'll just go over to a fact transaction, which is very standard. It's the web page hit transaction. So in every .NET Nuke site there is a site log, and you want to keep the web page hits for some time so that you can analyze the page hits on your site, right? That's as standard as you get. And so we're going to truncate the T1 table. We're going to insert into the T1 table with all these keys, not all of them being set, of course. A bunch of information about the transaction. Now, much of this is not available. We have this inside our data models, but really on the .NET Nuke site log, there's not that much. We got the host IP address and the IP address numeric. So we are converting the address, storing both addresses. And this is how we do the ETL joins to take the key strings and translate them into integers. We do a coalesce of the key with 0, and this is a parameter. You can have that parameterized. That is a sequence number. We put sequence numbers on the front of all our fact tables. So you'll see that goes to PKVF web page hit transaction. So that's a primary key. We stick an integer primary key, usually a big int, onto every fact table. We have the data on the fact table, and then you've got this SQL. You can download it, so you can go and look at this. Because it'll make a little bit more sense when you look at it. But we're taking the data out of the view and we're left joining it to all these what we call AT3 tables, and these are the dimension lookup tables. So if you're familiar with Informatica or DataStage, these are the equivalent of lookups to translate your keys into integers. And there's about 20 of these generated here. So in other ETL tools, one of the big productivity boosts we get is in other ETL tools you have to code this, okay, into the tool, whereas we're just generating it each time. And that's about 249 lines of SQL which is generated to perform the joins and get the keys out of these lookup tables, okay? And obviously those lookup tables are just a string key plus the integer. Yeah. We then say, okay, we tell it a key, and our default is abscess reference number string. We build a key for each fact table, and we say this key is going to be unique. And if we see it again, it's an update, not an insert. Okay, so that's the data warehouse architect's responsibility to build that key. And where that key is the same, we will perform the update. Where that key is not detected, this normal left join with a null, we will issue an insert. Okay? So you have this SQL, you can look at it and see, well, how exactly do they generate this SQL which performs this function? Okay, how exactly is that done? So feel free to go in and have a look at that. Now, of course, when you're talking about a reasonable data warehouse project, this has got a couple of hundred tables involved. There are some pieces of SQL that you need to maintain by hand, and you need to put them somewhere. So we put that in a directory called manual SQL. Okay, and you can see what these pieces of manual SQL are. You know, update sequence numbers, update the set to EDW flags, opening and closing batch processing. We have pieces of SQL for that. We also have programs for that, C++ programs for that. so you can take your choice of how you want to open and close your batch processing. We do have some IP address administration code. We do need to load the dimension tables from the dimension tables themselves into those AT3 tables just for lookup tables. And we have backups and some manual edits. So what I'm going to do now is take you through some of these. And here we are in update SeETL sequence numbers. So what you can see we're doing here is we're updating SeETL sequence numbers, and we're setting the last key allocated to the max of PKVM party and 0, where the update sequence is Z01 VM party 01. So this is for the VM party 01 mapping, going and getting the highest key left in the dimension table, also allowing for the fact that this might be the first time this has ever run, and 0 might be the right answer. Okay. So obviously we run this for safety at the beginning of every batch and at the end of every batch. So that is kind of the belt and braces approach, where you say we want to make sure we don't get any key clashes. So just in case anybody has edited the database since we last ran a batch against it, we're going to update the SeETL sequence numbers. At the end of each run, you need to update the row sent to EDW indicator, and you do that only on the cases of where the row is valid and its row sent to EDW is set to 0. So the condition of taking a row through a view is always EDW, row sent to EDW equals 0, and the row valid indicator is set to 1. So we only say that only those rows we know just got sent to the data warehouse get their row sent to EDW indicator equal 1 set. Now we do this in 3 stages, just because we like to break it up, and because the statement processor is limited to 32,000 bytes per file. So we can put a 32,000 byte file into the database and process it through our statement processor, and over 32,000 bytes it will issue a message and say I can't process that information. Okay? Actually what it does, it issues a message and says I can't load that information into that table. So we have that set, and they're the that's a DNN staging table. That should be the non-DNN staging table. Then this is DNN tables, and the last few DNN tables. Okay. To open a batch, it's insert into SeETL batch control. So a new insert, and it goes and gets the batch number and adds 1 with a default of 1 if it's never been processed before, and gets the batch date and adds 1 with a default of 1900-0101 if it's never been seen before. So that's inserting the batch control, and of course closing the batch is merely to say go find the batch where the batch complete flag is 0 and set the batch complete flag to 1. So those 2 pieces of SQL are very simple pieces of SQL. In IP address administration, you can see that we're using the functions in here to select host user address and convert it to integer. So this is from STG DNN site log, which you would all be familiar with, and it goes and gets the addresses from the site log and inserts them into the work01. And it does that where it detects that they don't exist already in the work01, and it groups by that. Okay. This then goes and gets addresses from STG DNN users. So users get their last IP login address stored as well, and we go and get those addresses. So this is all the known addresses. Each time we see an address, we go grab that address and put it into the work table. Another piece to go get those combined sets and put it into work02. And now we're creating the cross-references. We go get, in this piece, this is for the blocks. We go get the address and we look to see if it's between, the IP address we have is between GeoCity blocks from IP address to IP address. So we're getting the region, the location where we think this IP address came from. And then we go get the whois. We go use the GeoLite country whois table with the address to go find out which country we think the address is from. Okay, and we stick that into xref01. And then we update that into known IP addresses. Okay. So this is our little set of processing for IP addresses, where we try and detect all the known IP addresses that we've seen from our sites. And currently we're running at about 144,000 of those. Now in load dimension tables, you saw these AT3 tables in the fact table processing. They get loaded like this. They get truncated. So this is a truncate of the AT3 tables, all the lookups. This is the insert into the AT3 table, and it's selecting from these views, which was the file that you saw in the views directory called AO1 lookup views. Okay? Then at the end we run stats across those small tables, because when the volumes are large, not what we're working on, but when the volumes are large, you want to run stats on these tables to give the database engine the best chance of picking the best join mechanisms for each of those tables. Okay? Obviously there's a backup, so you can see the backup database to the data backups directory, and then a shrink afterwards, and another backup with the shrink afterwards. And of course in this kind of prototyping testing, the backup mechanism is simple, and the shrink will actually throw away the log data. Okay? But you guys have got DBAs, they'll be able to tell you how to do that. The next directory is the SQL directory, and this is where you just put any other SQL you want to have that's not part of the batch stream. So this is just selecting work data, this is some manual edits to the ETW flags, those sorts of things. Nothing much to be interested in there. Now that was all the staging area directories. We'll go over to the target now. And in DDL we obviously have a target database. We obviously have a set of target tables. And you can see these AT3 tables at the bottom. We'll go into a couple of these tables for you. So here are some typical tables. TD IP address. The tables are relatively meaningless names. You have primary key, level column, dim chart key field, date from, date to, current flag, table number, row deleted from source, batch number, file cycle number, view number, audit timestamp, source system number, and client number, which has a default built into it, but is always set. And the rest of the fields are meaningless fields. Okay, just nvarchar 2000 at the back, some timestamps, some dates, some decimals, some integers, a big integer, character 1. Okay. Over the top of that is laid VM address IP, and that has the real names in it. The same with web pages. These are all the administrative fields that we put on there that are needed, and then the data fields are carried on behind. TD0100 is actually the party table. Again, you can see this is all generated because you can see the party type integer, party long, short description, party long description, and then the data fields. 255, 120 varchar 255s, which we've actually created as nvarchar 2000 just for this prototype. You can make it nvarchar 255 if you want, it doesn't really matter. We do have the ability of maintaining multi-level aggregates in the C++ engine, so we tend to stick 9 aggregate keys at the back of each of our dimension tables, just in case people want to use the C++ engine. A web forum post transaction, obviously every time you post to a forum, that gets dragged through to the warehouse. So you get a primary key, a table number, you get the detailed keys, 40 of them allowed, and then you get all these other fields, 30 integers, decimals, etc. tagged to the back. An nvarchar max for the actual text of the post, row del from source indicator, which should be integer, batch number, file cycle number, view number, audit timestamp, source system number, client number, and then on fact tables for SQL Server you'll get the partitioning column, and this was necessary in SQL Server 2005 when we only had one partitioning key. We built the partitioning key out of 2 pieces to enable us to emulate multi-level partitioning. That's a forum post, and this is a web hit transaction. Same thing, 40 keys, and then a bunch of other data. Okay, so that's what's in the tables in the target data warehouse. Obviously, in any data warehouse there are a bunch of indexes, 146 items in the indexes here. This is all very standard, you can go read them. Now in the views, a little bit needs to be explained. It is possible to create a second database, which is your documentation database, and that can be in a different database manager to your deployment database, and you can apply referential integrity constraints to that documentation database. Now of course I just showed you tables, and over the top of that go meaningful named views. You can't put RI constraints between views in most databases. In most databases, RI constraints can only be placed between tables. Okay? So we have the ability to, from the same source code as you are generating your views, generate physical tables and then apply constraints to those physical tables, which can then be re-engineered through any data modeling tool. So you get your data warehouse database, which is tables and views and things like that, with no constraints, because constraints just slow down data warehouse, particularly ETL processing. And then next to it you have your documentation database, where the views are instantiated as tables and constraints are placed on those tables. Okay, so that you can re-engineer it into a data modeling tool and draw a diagram if you like. Okay, we tend not to draw diagrams anymore. So I'll take you into data modeling views and target views. Here we are in data modeling views. As you can see, it's generated again. Okay, and we see all these drop views, many of which we don't have. This is just the full list of views, which we may well delete from your copy. But here you see VM party, and we said TD0100, and we had varchar. Well, now you can see them being exposed as prefix, first name, second name, third name, web address, tax number, government identifier, marital status, all these sorts of things. So these things are the things that you would expect to see on a table called VM party, right? And down here further you'll see a solicitation transaction, where the detailed keys are exposed as whatever they're going to be. And then you have all the things like email file, email subject, email variables being exposed from the varchar fields. So these are the names you see in the data model. These are the actual names on the physical table. Things like the date table, solicitation dates, solicitation types, products, addresses, association codes, campaign information, sub-campaigns, response transactions. I'll go down here a bit further. Download item measures. And you don't really have to worry about what the SQL looks like because it's all generated and you just throw it all at the database and it all works, right? So that's the views that are being built out of the target data model. And then the target views are built out of the SeETL spreadsheet, the mapping spreadsheet, and these target views are placed over the top of the target data warehouse, right? Now in the ETL processing version, you don't need these target views, but they get generated anyway. These target views are only necessary if you're going to run the C++ engine, okay? But they're generated and you can keep them and look at them, do whatever you want with them. But you see Z01 VM Party A1 DM is placed over the top of VM Party. And I'll show you how this is documented, but I wanted to show you first how it's generated. Now again, out of this, shade over 2,000 lines of SQL is generated. Okay? So they're your data model views and your target views on your target data warehouse. Now again, in the target data warehouse we have run stats. We have no functions in the target data warehouse in this prototype. We have run stats, 115 items in run stats that need to be run against these target tables. We have the workbooks, which we'll take you through in a minute. There's no reports on this prototype. In terms of commands, there's only 3 workbooks, so there's only 3 commands there. In terms of data, not really much to report, except we do have the backup files. There is no DML on the target data warehouse. There is no SQL in the prototype on the target data warehouse, right? So now what I've done so far is show you all the generated code, because if you're watching this detailed presentation, you are very likely familiar with relational databases, at least, and most likely you are familiar with .NET Nuke and SQL Server. So by looking at the generated code, you can understand, oh okay, well, we have this connecting the ETL to the source database, the .NET Nuke source database, which has been unloaded from the ISP and restored. We extract data out of there, okay, I understand that. Through views, we do delta detection so that we compare the current version with the -1 version to get the deltas. We move the delta into the staging area. Yep, I can understand that. And from the staging area, we run through the ETL processing to push it into the data warehouse. Yep, I understand that. Okay. Now, if you're used to using SQL Server, then you're used to seeing some of this kind of stuff being implemented through SSIS. And that's fine. It can be implemented through SSIS as well. Indeed, if someone takes all this and puts it into SSIS and releases the SSIS packages for free, I would really like that, because the people who took those packages and then tried to maintain them would soon learn the difference between maintaining that sort of ETL mapping through SSIS at field level and maintaining it through SeETL, because you would find that the maintaining it through SeETL is far easier because of the workbook based nature of the tool, right? So as somebody who's familiar with databases, you will have recognized all that code. You can read all that code, you can understand it, and you can get the picture in your mind about how that all works. That's not too hard. The bit that people find hard about our software is, so explain to me again this piece about how you generate that code. Explain that to me again. Okay? And this is what we're going to do now. We're going to go into the workbooks in some detail, and we're going to explain to you how these workbooks work. And what we're going to do is just break the video here, because in the recording process we're at 45 minutes. So we'll break the video here and start it again. Okay, so here we are inside our workbooks, the workbook directory. And as we said, we maintain everything through workbooks. And then we have an application which reads the workbook and processes it and generates the code that you just saw. So where you see create tables or create views or anything else like that, the DML used for delta detection, all these things are defined through these workbooks. Now of course, you want to do all this stuff, you can define them in any way you like. There are plenty of data modeling tools out there. You can build all your tables and all your views in those data modeling tools. For .NET Nuke customers, of course, there's SSIS within SQL Server, and you can maintain all this stuff in SSIS as well, right? We are not arguing that there are not other tools out there in which you can develop, support and maintain the source code to do all this work inside the database. Our argument is there are no other tools out there that are as simple to use as what it is that we have developed. And we are experts in business intelligence and been doing this for many years, and we know that the simplest way to create anything is just putting instructions into a spreadsheet, right? The spreadsheet is a fairly humble source code development tool. So to put instructions into a spreadsheet and then to have an intelligent application come along, scan the spreadsheet and generate the code that you need is the simplest way to do things. It is the simplest, fastest, cheapest way to do this sort of work, and it will never be equaled. Nothing will ever be faster than a spreadsheet and an application, right? Because you have to store the directives of what you want to do somewhere, and that's either a file or an application or through a screen or something else like that. And the humble spreadsheet has proven itself over the last 30 years to be an exceptionally good way of capturing information. This is why there are so many things where people store data in spreadsheets. Okay. Now of course, if you don't do it properly, you do wind up in spreadsheet hell. Okay. So here are our set of spreadsheets. We'll just go through them again. A spreadsheet to link the staging area to the source tables. A spreadsheet to extract data from those links into the processing for the ETL. A spreadsheet to define the -1 tables. A spreadsheet to define the delta tables. A spreadsheet to define the DNN staging tables. A spreadsheet to define the staging tables proper. A spreadsheet to define the control tables. And a spreadsheet to define all the other objects that are necessary in the staging area. A spreadsheet to define the delta generation. A spreadsheet to define the batch schedules. A simple one for key management and code definitions, and then the statement loader, and then the mapping spreadsheet. Okay? So I won't go through them in quite that order. I'll change the order a little bit, but we'll go through these spreadsheets now. Okay? So this is a spreadsheet that's creating a link from the source to the processing. Now the first thing you have to understand is we implement variable substitution inside the spreadsheets now. This was a fairly recent addition where we can have a variable, any variable name, and we like to use 4 hashes, variable name 4 hashes, because that's impossible to accidentally put something into a spreadsheet somewhere and mistake it as a variable. Yeah. So we have the variables, and then we have what's being substituted into the variables. So as you move from machine to machine or database to database, etc., all you have to do is to go into the spreadsheets in some text editor like TextPad and issue a change all to something like this, and voila, you can move from one environment to another environment. So one of the big issues around, say, developing Informatica in data stage is the moving the mappings and the workflows and jobs and all this sort of stuff from one environment to another environment through development, testing, into production. All these things have their own issues around making sure that you have variables set such that the mapping itself shouldn't have to change from one environment to another environment. And this is how we handle that situation. We use variables everywhere through the workbooks, and we have one sheet per workbook that says these are the variable substitutions you need to make. And now we have the new thing with 3102, the license file. Okay, so now every workbook has to have a license file in it. We have a processing tab. This is all in the documentation, so you should go read it. And the processing tab tells us what we're going to do for processing when we process this workbook. Okay? And then in here are the generic object information. Now what we're doing in this one, we give it a target file name. So this is the file name, and you have target file name prefix. And if we go over to here, or generic view output, where's the target file name prefix? Target file name prefix is underscore zin, or zin underscore. So it's going into a file, zin underscore, and it's going to this directory. Okay, and that's where you saw those zin views in that directory. Okay, so it's going to put it into the target file name. It has an object owner, an object name, the drop command, drop view owner target file name prefix ASP.NET applications, create view owner target file name prefix ASP.NET applications as select star from, and you can see this is the database on the same server, DBO ASP.NET applications. So this is the select star from this table to feed it into that view. Okay, and there are 153 of these. So in this particular, a little bit less because that's the number of rows. So in this particular .NET Nuke database, there's about 145 tables that we're bringing in like this. Okay, starting at 8 there. So this is going to go create those views. Now what I'll do is I'll go run this. And the way we run or process one of those workbooks is we go to the command file, we find the view links, and we just double click, and it's going to run that, and we'll bring up the Windows Task Manager at the same time. And so here we see it said it successfully opened the workbook. Now it's scanning it to find out what's in it. It recognizes it's a full production version. Now it's processing it, and you can see the memory usage as it opened up the workbook, scanned it to find out what was in it, went and checked the key, found out it was a full production version, processed it, and then released the memory. Okay? Now that one runs fairly quickly because there's not that much in it. When there's more in it and there's more processing to do, it takes a little longer. And there's quite a lot of processing done by that workbook, okay, done by the VB application. Just to prove that it did actually run, we go to Z in Views. We see the 4th of the 8th, 2013, 15:34, which is in fact the time here right now. This is a sunny Sunday afternoon, and you can see that they were all updated at that point in time. So that's how you update, how you process a workbook. How you process a workbook is you just go to Commands, the one that's set up, double click on it, and it will process that workbook. Okay? Just to make the point, here is the log. Okay, the date modified, here is the log. We open up the log file, we see the messages, we see that it's 3102 log file, we see it starting, 15:34:13. What spreadsheet we're processing, you can see. Perform variable substitution, yes. Generate SQL for generic objects using case lower, SQL statement termination string go, the various thing, the license which is being used, the ADBC connection that's being used, and you see that it took from 13 seconds, 34:13, yeah, to 32, which was about 19 seconds to open the workbook and then figure out what's inside it. Once it had figured out what's inside it, it took 5 seconds to process it. Okay? So this is kind of how this thing works. It might take 20 seconds to scan the workbook and figure out what's in there, and then look at the directives, figure out the key, and then process it in a few seconds. Okay? That's your typical profile of how the SeETL application runs. Now, of course, you're not limited to processing just one workbook at a time. You can go click on 2 or 3 different commands and process 2 or 3 different workbooks at the same time. You just want a fair amount of memory in your machine. The workbooks allocate memory when they open up the workbook. There is a default of 100,000 rows per workbook, so you never have to worry about having too many rows in a workbook until you get to 100,000 rows. But it does mean, because we default to 100,000 rows, that it does chew up a little bit of memory when it starts up. And then when it releases that memory, the garbage collector for Windows takes a little while to release that memory. But we see that as a very worthwhile penalty, or trade-off, if you want to call it that, with having to worry about how much we're putting into any particular workbook. So that's linking source views. The next one we want is extracting views. So that creates the Zin views. We then want to extract out of those Zin views the actual data we're going to use to process. So you can see the Zin there. You can see that we set a 1 for source system, PK source system number, and you can see the view name coming out. Okay? You can see D means derived, M means move, S means from, so you see from DBO Zin ASP.NET applications. So we just created the views. This book creates the Zin views. This book creates the ZXT views over the top of the Zin views, right? Fairly simple. You can see that we're aliasing columns for primary keys and detail keys. Okay. Now in this extract views, and you have this, you can go look at this. There is 1,611 lines of code. Now it's very easy. Once you look at the workbook, it's very easy for you to understand, oh, this is what the workbook looks like. So what SeETL is doing is reading this workbook and creating the create view statements and emitting the create view statements. So what you need to get to are the create view statements. What we're providing is the tool to store the information most easily to get to the create view statements. And mind you, all this information is loaded into our dictionary so that it's searchable, right? So that's the extract views that are there. Next we're going to go to the M1 tables. The DNN N1 tables, okay? So what do you need to define a table? You need a table owner, a table name, a column name. Column number is optional, but it's handy. You need to give it a data type for the deployment, a data type for the documentation, a null clause for deployment, a null clause for documentation, and any other clause that applies for that row. That's what you need to give it for the columns. So what this is doing is giving all these things just for each column. Okay? Now at the end, on SQL Server, you need to also tell it that it's on primary, and the on primary goes in the other clauses. And then if you have any particular special clause, any other special clauses, you can just keep putting them on here. You can have multiple special clause rows. Okay? Now the N here is just to tell it that this is the last column on the table, and it is basically a cheat from us, the developers. When we see the N, we know to put the right bracket in. Okay? So if you don't put the N there, the right bracket doesn't get put in, and you may get an error in when you process the create table SQL. So you must have a B for begin, and an N for end, okay, and E for end down here, right? When you are finished defining the table, you must have an E. So N defines the end of the column definitions, and E defines the end of the table definitions. Okay? So this is how you create a table in SeETL. You document a table like this, and it will create the create table statements. And if you go down to the bottom, you'll see there's nearly 2,000 lines of create table entries in this workbook. Now obviously, if you wanted to have the M1 tables defined in any other tool, such as a data modeling tool, absolutely you can do that. We argue that by defining them in the workbook like this, they are much easier to create. Okay, that's our argument. And when you're having hundreds and hundreds of tables, we are experts, of course, in using data modeling tools. When you're having hundreds and hundreds of tables like this, it is far easier to maintain them in spreadsheets than it is in anything else. Okay? So we'll go to the next one, which is the D1 tables. And of course they're very similar, the D1 tables. The difference is that they have the delta indicator on the back. Okay? Now of course it's possible you might create a set of tables, and you might create a set of create tables from the create tables, a select star or whatever, and you might then alter those tables to put the delta indicator on the back. You might do all sorts of things to be able to create these tables. But I would remind you that all this information gets loaded into our dictionary. We have the deploy and documentation data types as different columns. So when you deploy or document this table, you can deploy. What we did this for was Netezza. We deployed to Netezza and documented on SQL Server. Okay. So I defy you to find yourself a data modeling tool which will allow you to deploy to one database type and document to another very efficiently like this. Okay? I defy you to go show me that. So the delta indicator needs to be added to all the D1 tables, And again, of course, it's pretty much the same number of tables, same number of rows, a little bit more because we've got the delta indicator, so roughly 2,000. So 2,000 rows of table definitions in here. The next one we're going to go to is staging tables themselves. Now the staging tables themselves contain all the other tables, not just DNN tables. And what we have in the staging tables also is we have these 4 columns added to every one of the staging tables. The row del from source indicator, the row valid indicator, sent to EDW, sent to ODS. Okay? And you can see the default values against those. Okay? Now when we scroll down, this one does just have the DNN tables in it. So this is 2,748 rows. So yes, it's stage tables just for DNN. So 2,748 rows. The only real reason for separating the definitions of all these tables is that you might want to have different people work on different table definitions at the same time. Okay, that's the only real reason. When we use the share spreadsheet facility of SQL Server, Excel, Excel does have a let multiple people edit this spreadsheet facility, but what we found was that it explodes the size of the spreadsheet about 10 times, and then the scanner, which goes scanning across the spreadsheet, its runtime goes up about 10 times because it's scanning all these fields and then it's throwing them away saying, oh, I don't need this, I don't need this. But it has to scan it to know that it doesn't need it. So we don't use the Excel share table capability. So you can go and have a look at that. The next one we have is the staging table loading tables. So we said we can do things like Outlook contacts. Okay, so here is the Outlook contact staging table. Email connections, LinkedIn connections, solicitation transactions. Indeed, if we go to the top here and drill, you can see all the different tables that we have in this particular workbook. Okay, and you've got these, you can download it, you can go look at it. Again, this is a bit over 1,800 lines of workbook which you will create tables from. Okay. The next one are the SeETL control tables themselves. These are tables necessary to control the running of the ETL processing, either the C++ batch module or the SQL generator module. Also, large amounts of documentation are put into this dictionary, business requirements, report definitions, all those sorts of things. And there's just under 1,500 rows of table definitions in this. Okay? So this is a great documentation tool, documenting mappings, documenting Informatica definitions, these sorts of things. We've been using this for years to do that kind of work. Then there is all the other objects that need to be created. So the first other objects are create indexes. So here's 310 lines of create index code, and you can see drop index, create index. So you put the create index text in there and you tell it what file it's going to be put into. And with variable substitution, you tell it where do I put tables, indexes, count SQL, create table as select. You tell it where to put things. Okay? So we create indexes, lots of them. And you can see over here on the right hand side, we'll just scroll down, you can see all the create index statements out there. Okay, so creating lots of index statements. And obviously these are created in text and just cut and paste into the cell of the workbook. They're then taken and generated and put out into those files, and we can just execute those files. Okay, but that too is also loaded into the dictionary, so you can see what indexes are created. The row count SQL that you saw is generated from this workbook. So it just takes this workbook and generates that standard SQL for you. All the create tables as selects are generated from this workbook. You can see the select into database owner, etc. So it's going to drop the table and then do the create, and it's going to put the output into that target file name. Okay, so that's maintained in there. All the create run stats that you saw are created here, documented here. You can see use database name, update stats with run stats. Okay, and there is 376 lines of create run stats minus a few for the headers, and a few other views: stage campaign, stage campaign group, stage campaign priority. They're all created. Campaign type. And some other views that are being created for you. So this is our workbook to create other views. Next I will go to Delta key management. These are the sequence numbers, and this is the initial allocation of the sequence number. So what we do is right at the very beginning we create the sequence keys. This is not strictly necessary. The code generated will do this for us if we forget to do it. Okay? But we prefer to specifically name the sequences through this workbook. We also have a last key used, which is not used with the SQL generation version, but is used with the C++ engine. So the key management, the keys need to be created and set to 0 when you're initializing the data warehouse. Obviously only done at initialization time. Code definitions. Every data warehouse needs a whole series of codes defined to it. So you could do email, brochure, telephone for campaign types, campaign priority, high, medium, low, member interests, maybe business intelligence, software development, child safety, law for the layman. These kinds of things might be code definitions. So you have a whole range of things which you can create for codes. Okay? And every data warehouse needs a whole bunch of codes. So they're fairly straightforward workbooks. Now what I'm going to do is I'll go through delta generation and the mappings before I go through the batch schedule and the statement loader. So delta generation. This is sold as a separate tool as well. You can just, if you want to just do delta generation for systems integration testing and regression testing, you can just buy the delta generation component. So what do you do with delta generation? Again, we've got the variable substitution. Give it a bunch of names. Say delta table suffix is D1, -1 table suffix is M1. So where you saw D1 and M1 everywhere, that's actually set through these variables, and these are the names we recommend. Now if you choose a different naming standard, that's really up to you, right? The directory that it's going into needs to be named as well. So you saw that it was in stage DML delta DML, and that's how it gets to be there. Okay. In processing, you say generate the delta definitions, propagate deltas to the target table. Do you want to append the standard 4 flags, yes or no. So these are all options within the delta definitions. Okay. So that's how you set up the delta definitions workbook, and then you just say the database name, source owner, source table name, column number, column name. So you have to compare a source with a target. It is assumed that this will be underscore M1D1, and if you want to propagate it to a target database, then you put in the target table. Okay. Again, you have begin when you're beginning a new definition, an end at the last column, and an E at the end of the definition. Now, the target table is the target staging table if you want to propagate the changes. If you don't want to propagate the changes, you're just doing delta detection for, say, regression testing, you would put nothing in the target, right? Over here, you have a column number for the target, you have a key field, yes or no, and you have test the field for changes, yes or no. So down here you see that this field says no, in announcements don't test the description for change, and that was because of an SQL error being issued for comparing the different data types, n-text and varchar, n-varchar max. So for each delta definition you want to create, you must tell it the key fields, so it can detect inserts, updates and deletes, and you must tell it the fields you want to test. Obviously it doesn't test key fields, okay, that will be ignored for key fields, but it will test the other fields and the where clause for the update, okay, the test for the update. Now obviously you have to define one of those for each delta you want to test. Again, there's a bit under, just under 1600 lines in here. It only took us about 40 hours work to complete this spreadsheet, and as you noticed from this spreadsheet we get over 1,000, just over 1,000 pieces of SQL generated. Okay, so if you stop and think about that in any data warehouse project, the idea that you can get this many fields tested through a delta detection facility and the altered rows propagated to the staging area is, in 40 hours work, is quite phenomenal. Now of course, if it's a large operational system that you're using, you might want to use facilities such as log shipping or something else like that to detect your deltas. But if you don't have that luxury, if you don't have the luxury of being able to use log shipping or something else like that, then the raw rub this version against the last version and give me the changes is pretty much what you have to do. Okay. And in the area of .NET New data warehouses, that's probably a quite doable thing, right? So this is how the delta detection works, and it generates all those pieces of code that you saw, right? But this is the source code. This is what you edit, this is what you change. And now we come to mappings, okay? And you have this, so you can go in and look at it, but it's fairly straightforward. The great thing about SeETL is many years ago we were having one mapping per tab, and as we got to more and more and more mappings, we had more and more and more tabs in our workbooks. And a bright spark said, well, why don't you put them all into the one workbook and put a drill on it? And I looked at him and said, well, what is a drill in Excel? I've never heard the term. And he looked at me like I was a little bit ignorant, and then he went away and he built a little spreadsheet and he showed me what drilling was. And of course drill is this thing. Okay, and everybody now knows what drills are on Excel spreadsheets, even me. Okay, so we can go into any of the mappings and see what's going on with them. So here's VM party. We can go drill into party A1. Okay, and it tells us what's happening in party A1. This is how we build the key. For each mapping, you must build a unique key that you want to say, when we see this key again, it's an update. This is where we get the key, the integer key from each time. So you can see key, where you see key, that's the string key. Where you see seek, that's the sequence number. Okay? And what happens is, you can see this is the table name, which may be a table or a view. This is a column name. And when we go down here, you can see the char indexes that we use. So in Outlook you have these things called categories, and you might say is current, and if that category, if char index finds is current in the category list, then you're going to get a yes. Okay, and that's going to be emitted out through this view. D1 means dimension table type 1. If I put D2 in there, that would be a dimension table type 2. This is the output view. So what it does, the SeETL view name is a view that's only known to the ETL administrators, and it creates two views out of each mapping. It creates the view you saw in the staging view and the view you saw in the target view. But it's using the one set of view names and column names to create both the source and target views. Now the reason for the source and target views and not mapping to the underlying table was a design decision which was made very early in the piece with SeETL. And that design decision was, we must never touch an underlying table, because if we touch an underlying table, we suddenly start forcing naming standards onto those tables, right? And one of the big issues with data stage informatica is, if you are touching the underlying tables, you are tying the processing to the table data structure. And this is a real problem with data stage and informatica, because then when you change the table structure, you have to change the mapping. Whereas what we do is we try and isolate the underlying table structures from the mappings through these intermediate views. Okay, that's why they're there. They are there as one of the best features of SeETL. It then goes through to a target table, through to a target column. If the target column is not named, then it won't generate anything in the mapping. Okay? So for example, if we go down to VM Party 02, you'll see some things don't have a target column. And when it doesn't have a target column, that means that that field doesn't go anywhere. Okay? This is the mapping to turn the email allowed flag off for an email reject. So the only target column going through is the email allowed flag plus the administrative columns, right? That's how this works. So as I said, you can go through and read this. We'll go down to web page hit transaction. Obviously in a DNN database, your web page hit transaction comes out of the site log, right? And so what we're doing with the site log is we're getting the date time off the site log to feed that to the date lookup. We're getting the date time to get the time of day off the site log. We get that out of the date time as well. We get other things such as source system number and the tab ID. The tab ID is the page that got hit, so we can look up the page numbers. We've got the host address. This is getting the key, so select last key allocated from SeETL sequence numbers for this sequence to generate us a unique key. We have things like when the user ID is null, then no, else yes. and this is going across to our was this hit by a subscriber. If the user ID is null, then we don't know who it is. Portal ID, referrer, all these sorts of things. IP address, we're using the function to get the IP address, those sorts of things. Okay? So when we go over here, we see the SeETL view name, the column name, the target table, and the target column name. Now in the SQL, you saw those AT3 left joins. Okay? You can go get the SQL again and look at it. The way that's defined in the spreadsheet, which is a really useful, cool way of doing things, we just say char key dimension table name. Okay? So this is going to create a view where this is coming out as the column char key dimension table name, the lookup that we have to do. The SeETL application detects the fact that it's listed as a char key, and it inserts that SQL that you saw into the fact table processing. Okay? So those of you who are familiar with SSIS or DTS or Informatica, DataStage, all these things, you're familiar with the translation of the input key to an integer within those tools. In our tool, this is how it's done. You say char key ZVM web host servers and put the resulting integer over here, and it will generate the SQL necessary to do that for you. Okay? Now, I've been doing this for 22 years. When I say I know this is the easiest way to do it, I actually do know this is the easiest way to do it. It's not an opinion, it's a fact. And so wiring up transactions to dimension tables via this kind of spreadsheet simple definition interface is simply the easiest way to do this. Okay? And then you have the administrative fields at the bottom. And if you don't believe me, then on our website we have a number of people who are expert in all the tools. And I too am expert in Informatica and DataStage. I've used those tools in anger on large projects. I know exactly how the ETL for those tools works. You can go talk to other people. You can take my word for it because I'm an honest man, but if you don't believe me, you can go talk to the people in our testimonials who will tell you, yes, in fact, we are experts in other tools and we know this to be the easiest way to do these things. And the best experts to talk to are our friends at Keywork, because they were DTS users and they did have to make the decision about going to SSIS or SeETL from DTS. They chose SeETL over SSIS, and they will tell you hand on heart that that was a great decision. Okay? So we are suggesting that those people who are big users of SSIS, if you take a look at this and you understand what's going on, hand on heart, this is a better way to do things. Okay? This is a much cheaper, faster, better way to do things than using SSIS for the vast majority of data that you're going to put into a data warehouse. Okay? Now, as we extend this to take care of other types of functions, we will become just as good as SSIS or any other tool. In fact, we would argue better, faster, cheaper, more reliable, more robust, higher quality, those kinds of things, such that you can rely on your data being in the data warehouse when you want it, the fastest, cheapest, most effective way, because we're doing everything in SQL inside the database, and the other tools are doing some work, if not large amounts of work, outside the database. Okay? And we argue we have the simplest definition interface. Okay? It's also Microsoft. So the definition interface, being an Excel workbook, is the simplest definition interface you can have for defining mappings. Okay? So that's how we define our mappings. And like I said, you have the spreadsheet. You can go look at the spreadsheet, and then you can go look at the output generated, and you can connect the two in your own mind to say, okay, this spreadsheet generates staging views and target views. I can see how that works. It also generates this SQL for the data manipulation. Okay, I can see how that works. And once you actually look into it and investigate it, it becomes fairly obvious. The usual resistance that we get is people say, I just can't believe that this spreadsheet can be read and processed and produce that stuff. So in order to overcome that quite irrational disbelief, we've produced it for you, given you an example, 3 examples in fact, that you can go and have a look at. And you can convince yourself that this command, which has 70,000 lines of VB code behind it, this one command, can analyze and process all these different workbooks and produce the output that's necessary and load it into the dictionary, right? So believe me, the SeETL command is over 70,000 lines of code now. So that's what happens when it opens the spreadsheet. It has 80 different tabs that might be in this spreadsheet. It goes scanning the spreadsheet, figures out what's in it, and then asks the processing spreadsheet, what should I do with the rest of this data that I found inside the spreadsheet? That's how this works. Okay? Which is why, some people would argue the runtime of the spreadsheet is a little slow, but compared to the time that you would need to spend to do this any other way, it's extraordinarily fast. Okay? So that's the mappings, and it's going to produce the SQL for the staging views, the target views, and the DML to move data from the staging to the target. That's what is going to be generated out of the mapping spreadsheet. Okay? Now then, what do you need to do? You need to load all those statements into the database, because we actually run the ETL processing from inside the database. Okay? We take the data from the DML folder, all this delta detection stuff, etc. We take that and we load it into the database. Okay? That file gets put inside the database and managed like any other piece of data. We also put everything else in there. The fact table processing, etc. The row count processing, the manual DML, and we put all the create table DL into the database. And I'll show you that in a second. So all the SQL that we're creating all gets put into the database and is available through reports, so that you don't have to go to the directory structure to find them. This means that people who are supporting the data warehouse processing can see this SQL without knowing the directory structure, without knowing where anything is. Okay? So that's part of why we are loading everything into there. Now it's also versioned. All SQL, as it gets loaded into that database, gets versioned, so you can see the past versions of the SQL. So as people change tables over time, change views over time, change mappings over time, we keep versions of everything inside the staging area database in this case. Now because it's in a database, you can be as large as you want, right? It's not going to slow anything down. When we execute this, we go after the current flag equals 1, and that's on an index, so it doesn't, having one version, 10 versions, 1,000 versions of a piece of SQL does not slow down the batch processing appreciably. Okay? So having versions of everything that you've ever loaded is really, really very nice from an audit point of view. So that's what the statement loader is about. Okay? Taking that information and putting it into the statement load table. And if we look at that, the statement load table will be here, SeETL031 SQL statements. So SeETL031 SQL statements is where you will find all the statements that can be executed against this database. Now, of course, the last thing you need is a schedule. Okay? So nothing runs without being put through a scheduler. So what you've seen today is you've seen all the SQL code that's generated, tables, create indexes, run stats, all those sort of things, the DML code that's necessary, the one-off handwritten code that's necessary, and that's all sitting there now through the statement loader in the SeETL statements table. But now you have to execute the statements in that statement table. So how do you do that? Well, you need a schedule, and you need the schedule to be triggered by something. Okay? So with each system, with each SeETL system that's implemented, one per customer, you get one scheduler. Okay? And that scheduler can have many batches in it. So you give them the name of batch 01, 02, etc., and you have a maintenance batch 01, 02, etc. Okay? And you can have a whole series of prerequisites of different types, and you can read about them in the manual, but you can have it on the day of week, a day of month, a start hour, a start minute, or a start timestamp. Those are the sort of prerequisites you can have for a batch. Of course, 99.9% of batches are triggered in data warehouses are triggered by the presence of a file. So when everything is prepared and the batch is ready to run, data has arrived from all different places, etc., and some mechanism, either a human being or a program, has decided that it's time to run the batch. What they do is 99.9% of the times put a file somewhere that the scheduler will detect has been created and say, okay, I've now been told that it's time to run the batch. This file's here. And in our case, it is the batch run yes file in the staged data directory. Okay? So when this file is present, the prerequisite type is file exists. When this file is present, the batch will run. Okay? And what does it do? Well, this is what it does. It executes all the statements in the various groups. Now, with our scheduler, you can run multiple batches at the same time, and each batch can be made up of processing groups. And the processing groups can be parallelized, and you can sort out the parallelization of that. So why is this important? Let's say you're a telephone company, and let's say you have 100 million CDRs a day, which is not a big telephone company. 100 million CDRs a day is, in a bill run, is not particularly large for a telephone company. You'll get that in a country with 15, 20 million people, right? So in big telephone companies, it's way more. But let's say you have 100 million call records that you want to put through into your data warehouse in a batch. If you process them sequentially, you might be a while about that, right? Unless you have an Intesa machine or something else like that, and it itself will parallelize the batch stream, right? But if you have SQL Server, and SQL Server is not going to parallelize the batch stream, you want to parallelize that yourself. And this was what we had with our C++ engine. With our C++ engine, we were performing the processing, and we had to parallelize that processing ourselves. So the way that we do that in telephone companies is we take the last digit of the telephone number and the last digit of the customer number, and we mod that through a separation process. And so we take the the CDR files, and we put them into the staging area, then we pull them out again using the mod of the telephone number and the customer number, and that gets us 100 files. So we have 100 streams to process. So if you have 100 million CDRs, chances are, by logic, chances are you get around 1 million rows per file. Okay, and 1 million rows per file is about right. And then you take that 1 million rows per file and you throw it through the attribution process in parallel batches. Okay, and you parallelize the batches and the process groups based on how many CPUs you have and how heavily you can saturate the machine before you thrash it to death and it starts going too slowly. Now what we found in most telephone companies is we could do that processing using our ETL subsystem faster than DataStage could. Indeed, when we implemented the ETL into DataStage in the telephone companies that we did that for, we could schedule the DataStage jobs through our scheduler, and we could get through the batch processing about 30% faster than DataStage could get through the batch processing using the DataStage scheduler. So the only difference was we had our scheduler and DataStage had their scheduler. We ran the same DataStage jobs. SeETL can run DataStage jobs from the SeETL scheduler, okay? And we can make DataStage jobs part of our schedules. So we were able to balance the load better than the DataStage scheduler and get done 30% faster. So our friends and colleagues at IBM spent some time improving the scheduler, because that's a bit embarrassing, right? That a scheduler written by an ex-IBMer can be better than the scheduler written by the current IBM lab. So what is in the schedule? Well, the first thing it does is update the SeETL sequence numbers. This is not executed at this point in time. It updates the sequence numbers, and then it goes through all the delta processing process. So you can see DLP, there's the 7 pieces of code for each delta processing piece of code, and we'll just scroll down. So it's doing all the delta processing, right? That's the first thing it does in the batch. Once it's done the delta processing, it will do the IP address administration code. Okay, those 6 pieces that I showed you. And you can go and look at this. You can look at the batch and then you can look at this. Then it's performing the row counts. Then it's performing the DML folder for ETL processing, the code that's generated out of the mapping workbook. It performs that processing. For dimension tables, these are the dimension tables. You see VM web page portal, campaign priority, web forum, host servers, download items, parties. So this is the ETL for the dimension tables. It then takes the results of the dimension table processing and loads them into those AT3 tables. So you can go and now look again at that SQL to see what it's doing. And then it's performing the fact table processing. Now in this prototype there's only a small number of fact tables that we're processing, right? And you can go look at the page hit transaction facts again to see exactly how that's working. So this scheduler will execute that SQL from inside the database and log it. It's then going to, for belt and braces, update the SeETL sequence numbers again, update the set to EDW flags to tell it that this data has now been processed. It's going to delete the wait file, so it's going to delete the batch run yes file so that it will close the batch. It waits for 60 seconds for everything to stabilize, and that gives it a chance to say that the batch is closed. The scheduler wakes up every 30 seconds and checks what's going on. So if we give it 60 seconds, it'll wake up and say, ah, the batch is finished. I can end now. Then it will delete the file, close batch processing. Oh, sorry, close batch processing is not there, is removed. It will delete the wait file, delete the run file, delete the wait file. Okay, and then we'll close batch processing. And that's what the scheduler does. The scheduler is the mechanism by which all this actually gets executed. Okay? And that runs in 5 to 10 minutes depending on your volumes. Okay? So pretty fast. So that's what the batch scheduler is doing. Now what I didn't take you through was the workbooks in Target. So I'll now load the workbooks in Target and take you through those. In the Target workbooks, there are only 3 workbooks because there's no data manipulation going on in the Target in this prototype. Okay, there is the data model itself, there are the other objects that are necessary, and then the statement loader for that data model. So this is all that's necessary to define a data warehouse data model is a couple of workbooks. And we'll go across to those workbooks now. We'll start with the data model. Inside the data model, there are tables that are needed. Okay, and base tables, data type deploy, data type documentation, deploy null clause, documentation null clause. So you can see the null clauses and the definitions and these sorts of things. Okay, they're all there. You can go through this and you'll find that there's a shade over 5,000 lines of create table statements in here. These are all the tables that are necessary to be created in the Target data warehouse. So quite a large number of tables, right? And this is only a very small, simple data warehouse. Okay, I want to emphasize that 5,000 lines for a data warehouse is fairly trivial. If you look at our data models for BI for All, the full data models, we're past 30,000 lines in the workbook now for data model views. So in data model views, this drill is on. We'll take that off. For data model views, we define all the tables that are possible to create there. And then we have the data model themselves. Scroll down, coming down. Then we have the data model itself. Okay? And we've only released a small portion of the actual tables. Okay? So in the top half, all the tables are listed, but it doesn't tell you what's in them. It gives you an idea, of course. If you look at the table name and see the table name, it gives you an idea of what would be in it. But then we have the table listed down here. And we have the column name short help, column name long help, and we have up to 10 languages that columns can be defined in. Okay? So if we go over to here to the language, view name lang01, language of 1 being English, of course. These are the tables in the prototype warehouse which we are releasing. So web page transaction, you can see the underlying table name, you can see the underlying column names, and then you can see the view name and the column name presented. Okay? Now we are arguing that this is the fastest, easiest, best way to maintain table to view definitions. And it gives you the ability to have the view definition in up to 10 languages. Okay? Try doing that in any other data modeling tool. If you can, show me. I'd really like to see a demonstration of having up to 10 different languages over a single base view in a data modeling tool, and how that might be maintained any more easily than just putting cells into a spreadsheet. Okay. So this is how our data model tool works. Now we can put data model joins into here, and those joins will be used for referential integrity constraints. And in our BI for all models, we do have, I think it's about 6,000 lines in our data model joins. We have actually implemented all the joins. Okay. So you can go through all these, VM address IP, it has the underlying TD address IP coming out through VM address IP and the various fields from that. Okay, so this is our data model. This is how we maintain it. We just run SeETL over the top of it and it generates everything we need. So that's what the data model looks like. The database other objects, we have to create indexes. Okay, so all these, you can see the create index statements. Lots and lots of create index statements. Okay. They're all created by hand, cut and paste into here so that we can find them. Creating run stats, you have to run stat all these things. No other views, it's there for completeness. No other create table as select, that's just there for completeness. Okay, so you can download that spreadsheet, you can have a look at it in detail. Lastly, the statement loader, all these things, despite the fact that it's not strictly necessary, all these things are also loaded into the dictionary so that they are published and anybody who wants to read them can read them. So that's just a straight statement loader. Now to prove that all these statements are loaded, I'll start up our reporting engine and show you what's in the reporting engine. Now I am using Firefox as the viewer for the reports because, believe it or not, Firefox actually presents report services reports nicer than IE10. Okay. So here is our SeETL031 IBI. This is our website, our company website, SeETL reports, administration. Here's the set of reports in here. We'll go to batch schedule combined, and this will actually show us the schedule that we have loaded. It's just running. We can select the batch name we want. Hit view report. It's going to go get us the batch name again, and we can see that this is what was in the spreadsheet, right? You scroll down. If we go a long way down, we'll see the ETL processing, what it's telling us it's going to do. So that's the batch schedule. Yeah. It has the batch prerequisites, the process group prerequisites, and the commands which are going to actually be run. Now let's see batch run log by status. Okay, this is actually a run log. And we'll click on that and it will go get the latest batch that has been executed for us. And we see that it was batch number 5 and it took 4 minutes and 4 seconds to run. Okay, we have the parent process IDs, etc. of the bits and pieces of the scheduler. This is the database connection it used, this was the catalog it used. Okay, and then you can see this is the start timestamp, end timestamp, elapsed time, status, process IDs that we used, so you can see how much time each step took. And of course each step doesn't take very long when it's just a small database being run on a SQL server. So you can go all the way down here and you can see these things being run. Now we'll try and find a little bit of fact table processing down here. Okay, here's our web page hit transactions. Run successfully in less than a second. Okay, so we couldn't detect more than a second of processing time there. Updating the sequence numbers, 1 second. Updating the EDW flags, couple of seconds, because this is all incrementally extracted and updated, right? So that's kind of how that goes. That's the actual execution of a batch, 4 minutes on our little data warehouse. And this is executed SQL statements. So if we click on there, we can select spreadsheet, statement loader, all the different directory names, things we're loaded from. So we'll just say all and select a value and hit yes and hit view report, and it will go and get us the statements that were executed in this batch. It'll be a little while because there are a lot of statements executed, right? And for each statement it produces a line. So we'll see start, stop, number of rows affected, and elapsed time, right? So we can scroll down here. Here we see site log. There's 53,000 rows in the site log for our warehouse. We truncate the site log on a regular basis. If we scroll down to see page hit transactions, we see facts. There were 143 hits on the site in the roughly 24 hours that were between batches. Okay, so when you're looking at 143 hits, that's not very many hits, and that's why it only takes 4 minutes to run the processing, because our company website is not very hot at the moment. Okay, hopefully it will get hot in the future. So that actually shows you that the SQL statements are logged into the database and available to you via reports. And what I'll do is I'll take you over to the statements themselves. You get SeETL reports, metadata, and they're down the bottom here somewhere. SQL statements. You click on there. You select the spreadsheet. Ask it what directory, and you can see all the different directories. So if we say tables, yes, we could select different Windows users if different people loaded them. We can pick out the particular file that we want to look at if we want to, but we'll look at them all. So I want to emphasize that we have the SQL loaded into the database with the directory name and the file name available for everything that's generated, and even the handwritten SQL. Okay? So here are all the different file names. I can go pick one, create table as. It's telling me who loaded it, what workstation, what domain, what Windows version, what .NET New, what SeETL development version, where was SeETL located when it was loaded. And then drill again and we'll get the actual piece of SQL that was loaded. Let's just get rid of this. Okay, so you can see this is the SQL that's generated out into the file system. It's been loaded from the file system into the staging table, and it is executed from inside the staging tables. Okay, so the reason that I want to keep emphasizing that is this means every piece of SQL that's used in the warehouse is loaded inside the warehouse itself and versioned. And who loaded it, when they loaded it, where they loaded it from, how they loaded it is also on every version. Okay? So those people like me who were brought up in high security systems like billing systems and pricing systems, which is where I cut my teeth as a youngster, people who live in those areas know and understand the importance of making sure that you know what code was running against what databases when. Okay? So in the metadata reports, there's lots of metadata reports for your business requirements and project objectives and critical success factors and all these sorts of things. Source data descriptions, your data model can be put into here. Lots of things get put into the metadata dictionary, and the metadata reports are all about the things that are static within the system, and the administration reports are the reports about what's necessary for the execution of the ETL subsystem, which is why you have audit records, you have error messages, batch prerequisites and scheduler controls and those sorts of things. These are the sorts of things that are necessary by the operator of the data warehouse to be able to see and understand and run. So let's say you are a company that has .NET Nuke or similar, and you say, hey, this all looks pretty cool. If we take all this stuff as is and we just use his tools to maintain this stuff, or we maintain it ourselves, when we run our batch processing overnight, whoever's responsible for running it, they can go and see what's happening in the batch schedule. And these are the days of being able to work from home. Whoever's going to look after it could work from home. Now, inside the batch scheduler, if something fails, you can execute any command. So one of the things that you might execute on failure is a pager message. Okay, if you have software on your server that can send a pager message or send an email, high priority email, you can execute that on failure of any step. So if a step fails, you can notify whoever is the support person via a pager, for example, or via an email. Okay? So that's how that works. You get all that. The only bit that you're paying for is the SeETL application itself, which is licensed per user per annum to take the spreadsheet and generate what it is that you need. Okay? That's the piece that we've licensed now and that we can protect and get people to pay for. Okay? So this is how this works. If you are a company that has DNN and you have that running on a hosting service, and you say, well, we don't have the knowledge or the skills in-house to build this data warehouse and run it, etc. We use a hosting service and we use some consultants. You can say to your consultants or hosting service, hey, we'd like a data warehouse like this. It's cheap and cheerful. It's virtually for free. But we want you guys to host it and run it for us, please. If you need some advice from Instant Business Intelligence or Keyword Consulting, go get that. Make sure it's itemized on our invoices, etc. And let's build this thing such that we can get good business intelligence out of our .NET Nuke site, right? You could do that. Or if you were the sort of company that said, okay, we're a fairly large company, we've got a fairly large .NET Nuke site, but we take our orders through our operational systems and we have other systems that we have data in. So, this looks like a nice starting point for us to be able to build an integrated data warehouse which integrates .NET Nuke with the other sources of data that we have, and we can create a more comprehensive picture of what's going on in our business by using all this. Sounds interesting. If you have the people and the skills internally, go for it. If you need people and skills on normal European rates, we can sell you the services of Keyword Consulting. If you just want to do it with some local consultants who've been trained on this sort of stuff, let us know. We'll see if any of the people that we've worked with are available to come to your place and do this work for you. Or you can offshore it to us and we'll do the work for you. It's There's no problems. So what you're getting as a starting point in this package is a whole data warehouse built up out of .NET Nuke. Now if somebody wants to get us to build a similar thing with Microsoft Dynamics or Oracle applications or anything else, we'd be quite happy to do that. Indeed, we've done plenty of Oracle applications projects. The reason we're not releasing anything with Dynamics or Oracle applications or these sorts of things is that the data models of those things are protected intellectual property, and we think that if we, a small company, go thumping around in their applications and building this kind of ETL, that the first thing we're going to see from our friends at Microsoft and Oracle is a lawsuit claiming that we've interfered with or repeated their intellectual property. Okay, whereas with .NET Nuke, being an open source portal project, I'm sure that Sean is not going to send us a lawsuit by promoting and publishing a low-cost business intelligence solution off the back of .NET Nuke. I don't think Sean's going to be doing that. Indeed, I did send Sean a note to warn him that we were doing this, to give him the chance to reply. And he didn't reply, which I take as, that's fine, go for it. If you guys are able to do something that promotes a low-cost solutions around .NET Nuke that makes .NET Nuke more popular, I'm sure Sean wants to see .NET Nuke more popular. And what we're doing is providing a low-cost solution around .NET Nuke, which will enable a much better business intelligence to be extracted out of .NET Nuke websites. So I'm pretty sure that we won't be seeing a lawsuit from Sean anytime soon. But if I were to do the same with Oracle and Microsoft, I'm pretty sure that we'd be seeing some objection from them in the very near future, and that's why we're not doing it, right? So if anybody wants us to do it for you, and you have a confidentiality agreement with Microsoft or Oracle, and you'd like us to also sign that and then to do the work for you specifically and not publish it to the broader world, we would be only too delighted to do that. And as I said, we have already done many Oracle apps implementations, and we do have lots of intellectual property and collateral for Oracle apps. We are just not making it public, okay? Because we signed when we did those projects non-disclosure agreements saying we would not disclose anything that we know about those Oracle apps, data models and how all the data works within Oracle apps. So if you are an Oracle apps customer and you've got those non-disclosure agreements signed up and we sign up to your non-disclosure agreements, we have a large amount of collateral that we can bring to the party that we can't talk about until we get there. Okay? But you can obviously understand that if we've built workbooks like this before for large Oracle apps sites, that we have a very good handle for what's happening inside Oracle apps. Okay? Now just going back to our presentation, what did we show you? In the summary presentation, we just told you what the list of workbooks were. In the presentation, the detailed presentation that we just showed you, we showed you what's inside each of the workbooks, and you've got the workbooks and you can go and look at these things for yourselves. Okay. We also showed you the code generated by SeETL from each of these workbooks. And it is a very simple matter for you, if you want to learn this stuff, to go and look at the workbook and look at the code generated, and it's very easy to understand once you do that, oh, this VB application, which is 70,000 lines of code, scans this workbook, manipulates the text to produce this output. Okay? Now, how it scans the workbook and how it manipulates that application, you don't care. That's a black box to you. You can see it happen. You can download this stuff. You can double-click on the commands. You can test it yourself. If you download this and put it into the same directory structure on your C drive, then you can execute all this stuff to see that it does work like that, right? So having seen the workbook and seen the output and understood how the output works in building a data warehouse, you then have the choice. Do you just take the output and carry that forward in whatever maintenance tools you want to maintain, or do you want to license just that executable program such that you can take the workbooks and build on the workbooks themselves, okay? And that is if you want a data warehouse that is a .NET Nuke based data warehouse. If you don't want a data warehouse which is a .NET Nuke data warehouse, then chances are you shouldn't be listening to this presentation in the first place, right? But if you've got to this point in this presentation, which is a couple of hours in now, you're obviously interested, and if you are interested, your choice going forward is take the work that we've done for free, it's all free, take the work that we've done, carry it forward to build your own .NET Nuke data warehouse, or take the work that we've done, license the SQL generation portion such that you can maintain what it is that's been done inside using SeETL. And that license is €7.99 or near equivalent per person per annum. So our argument is for €7.99 per person per annum, which is one consulting day at a modest rate. Okay, the €7.99 comes from €100 per hour is a modest consulting rate in Europe today. Okay, so if you are not prepared to pay one consulting day for the tool that will maintain all this, you say, I will maintain it in something else. Our argument is you will spend more than one consulting day per year maintaining this some other way, right? And given that you will spend more than one consulting day per year per person maintaining this some other way, the license fee for SeETL is a bit of a no-brainer. Okay. Now, we did used to license SeETL for quite a whack of cash because it had no license in it, and it was used for everybody in the company. When it was sold, everybody in the company could use it, right? So the license reflected that. All the ETL developers could use it. Now the license reflects, named users. You can use it. Joe, you can use it. John, you can use it. Mary, Sue, that's it. 4 of you. Nobody else can use this. And if they do, that's a license violation, right? So that's how this has been set up. You now have a decision. If you are a .NET Nuke site, or you have .NET Nuke portals, or you're a .NET Nuke hoster, or you're a .NET Nuke consulting firm, you have all this information in front of you. You have the thought of, should we be getting into .NET Nuke Business Intelligence? Should we be integrating DNN sites into broader, wider data warehouses? What exactly should we be doing with DNN and Business Intelligence? You have that question in front of you. You now have a very comprehensive tool and set of directives in front of you about how to build that, and you have a choice about how you maintain that. We would love you to make the choice of using our tools, of course, but if you want to use somebody else's tools, then go ahead. If you want to do it in SSIS, then go ahead, because there is no way that anybody else can do this any cheaper, any faster than how we are implementing this stuff through workbooks, right? We've been doing this for more than 20 years. We know this is the fastest, cheapest way to do this kind of work. Now, I did take you through the outputs of all the workbooks, and we did take you through a very detailed review of tables and views and everything else that's there, and you've got all that information in the download. Okay? So what did we take you through in this detailed presentation? We took you through the actual directories, the actual detailed components of the warehouse, through the actual workbooks one at a time to show you what's in there and how they work and what they generate, meaning the output of the workbooks, how to run them. Just go to the command line, double click on commands and it runs, and a detailed review of the tables and views that are there. Okay? So this has been a very long presentation. Thank you for sitting, if you're still listening, thank you for sitting through it. We think that we have released something that is extremely, extremely useful to the .NET Nuke community. We would like to see lots and lots of people building lots and lots of data warehouses off the back of really cool .NET Nuke sites which are hot with sales. We would love to see all that, right? We would love to see people using our data models to target solicitations out through emailers and stuff like that. So if you've got a .NET Nuke store or website, we backed our store up with FastSpring. So if you've got a .NET Nuke site selling stuff using FastSpring or a store for DNN, and you want to send out solicitations and all these sorts of things that you want to do, run campaigns, all that is built into the BI for All data models, and it's all easily integrated with .NET Nuke today. The BI for All data model is easily integrated with lots of data from lots of data sources, and the integration is done in SQL through these kinds of workbooks. Okay, so what you've seen is the new way, the reinvention of how to build the infrastructure for data warehouses. Now we do have reports on top, but we've stabilized those, and other people who want to build reports similar in whatever tool they want to build them in, we're quite happy to give them the source code of everything we did, and for them to build reports just like ours on top of our platform in whatever tool they like. Okay, and that's really the tool developers for those tools would be the people who are interested in creating a front end for what it is that they've seen so far. And with that, I'd like to say thank you very much for listening to this very lengthy presentation. I hope you got a lot out of it in terms of the details that are there. Okay, what we wanted to do was put into this presentation all the details you could possibly wish for to be able to sit down yourselves and evaluate, do we want to go down this path to build our .NET Nuke based data warehouse, or do we want to go down another path? So by the time you've got to the end of this presentation and you've gone through the downloads and you've studied everything, there should be very few questions in your mind as to whether you want to go this way or go some other way. Okay, we hope that we have provided you all the information you need to make your decision. If there's something else you think you need to ask us to make your decision, by all means contact us at support@instantbi.com. We'd be happy to answer any and all questions, or jump onto our forums and ask your questions there. Okay, so with that, thank you very much for listening.